For a Y-connected generator, the zero sequence impedance is equal to the positive sequence impedance. This is because the zero sequence current flows equally through all three phases, resulting in the same inductive reactance as the positive sequence current. The software likely uses formulas to calculate the positive and negative sequence Thevenin impedances from the three-phase fault current, represented as IP, and the short circuit ratio, represented as X/R. The formula to calculate the positive sequence impedance, shown, is IP, times X/R. The formula to calculate the negative sequence impedance, C2, is IP, times 1 divided by the quantity of 1 minus X/R. Calculation should use the following value for the three-phase fault current IP, equals 1 divided by X''D, which is the subtransient reactance. If hand calculations are still significantly different from the software results, firstly, consider the software may be using a different calculation method or considering additional factors. Secondly, there may be a typo in hand calculations or the information provided by the generator manufacturer. Thirdly, the software and the calculations may be using different base values. The X/R ratio is a measure of the relative strength of the inductive and resistive components of the generator's impedance. A lower X/R ratio indicates a more inductive generator. The power factor, 0.8 in this case, is considered when calculating the rated current, but it does not directly affect the Thevenin impedances. The rated current I rated equals 250 divided by 0.8 divided by the square root of 3 times 0.6, which equals 300.7 amps. IP, equals 1 divided by X''D, which equals 1 divided by 0.12, which equals 8.333. The three-phase short circuit current equals 300.7 times 8.333, which equals 25 of 5.83 amps. For a line-to-line fault, I sub A1 equals 1 divided by the quantity X2 plus X''D. Determine I sub B. I sub B equals a square times I sub A1, and so on. For a line-to-ground fault, I sub A1 equals 1 divided by the quantity X2 plus 1 plus X''D.